So today we're starting Unit 6, and all of Unit 6 has to do, again, with rational exponents and radical functions. So we're still working with square roots, but now we're looking at how square roots and exponents are related. So we have, today in 6.1, we're evaluating what we call nth roots using rational exponents. So we are going to not just be taking the square root or the cube root of things, we're going to be taking the fourth root or something higher as well. We call those nth roots. So let's look at a definition first. If the nth root of a, if we have some number b raised to a power n and that equals a, then we call b an nth root of a. Now we can look at this in a little simpler example. So we know that 2 to the third power equals 8. So we would call 2 a cube root of 8. So that's all that it means, is that when we take the cube root of 8, we get an answer 2. So we call 2 a cube root of 8. So this definition up here is just in general terms. Here's a specific example of that, just to get some notation and vocabulary. So what we really want to look at is how exponents and radicals or roots are related. So if we are ever raising a number to a fraction, we call that we're taking the nth root. Now this term up here, the n, is called the index. So whatever the denominator is, if we are ever raising a power to a fraction, this first term, the numerator, is just like a regular exponent whenever we're raising a number to a regular exponent. So for example, 2 to the third. Okay, that would be like this numerator. But if we have a fraction, something over another number, that denominator becomes the index of the radical. So that's what we call the nth root. Now these two different types of notation do have two different names. If we are writing the number with the index to a radical or a root, that is called radical notation. So notation that has the index to a root is radical notation. And we call the notation that is raised to a power, that is a fraction, rational exponent notation. And we're going to need, today, we're going to learn how to be able to go back and forth. So the first few examples, all we want to do is we want to write the term that is in rational exponent notation, and we want to put it into radical notation. So that's all we want to do for these first couple of examples. So example 1, x to the 1/2. Now, this numerator is telling me what the exponent is. This denominator is telling me what the root is. So to rewrite this, this would be the same as a power of 2. We call a power of 2 squared. So when we take something with a denominator of 2, that just becomes a square root. So this would be the same as the square root of 8. Now whenever we take the denominator, that goes inside of parentheses, and this exponent goes on the outside. So this would be the same as square root of 8. All to the first power, but since it is to the first power, we don't have to write it, so we can just rewrite this as the square root of 8. So the denominator tells us what the index of the radical is. The numerator tells us what the power is. And any time we have a denominator of 2, that's just the same as taking the square root. So let's try another one. Example 2. We have 7 to the 1/3. So this 3 is going to tell me what the radical nth root is going to be. So I actually want to take the third root here of 7. and all of that is being raised to the first power. So all I did was I took that denominator and I changed it to a radical. This time we're taking the third root, and this little number is telling me what root I am taking. So it's the opposite of an exponent. And we're raising that to the first power, but since it's a power of 1, we don't have to write it. So this is the same as the cube root of 7. Now we have our square root and we have our cube root, and then anything after that we just name it the nth root. So our next example, 21 to the power of 9 over 4. Since our denominator is 4, we're actually taking 21 to the 4th root. So I make my radical and I put my index of 4 and I put 21 on the inside. And then it's all being raised to the 9th power. So I put it in parentheses and raise it to the 9th. And this would be your final answer, because your instructions are not asking you to simplify or to solve. They just want us to rewrite in radical notation. So we're just going from one notation to another at this point. So that's all we have to do to go from rational exponent to radical. So let's try going backwards. So this time we want to go from radical notation and put everything in rational exponent notation. So I have the 5th root of 8, and there's no exponent here, so that's the same as the 5th root of 8 all to the first power. So I'm going to take this index, and that becomes the denominator of my fraction. So this is going to be the same as 8. Our exponent is 1, and our index is 5. So this is the same as 8 to the 1/5 power. And that's all I'm asked to do, is to write it in exponent notation. And we're done. So let's try another one really quickly. Example 5. So we have the 8th root of 15 to the 3rd power. So this index is going to become my denominator. So I'm going to rewrite this as 15. The numerator is the 3rd power over 8. So 15 to the 3 over 8. And that's all I'm asked to do. So now we're just going from radical to rational exponent. So let's actually try simplifying or evaluating some of these. So what we have here, now we want to actually simplify all the way and evaluate these guys. So I have 4, in example 6, 4 to the 5 over 2. So this denominator becomes my index. So this is the same as, since this is a 2, it's a square root of 4. So we actually don't have to write this guy, all of that, to the 5th power. Alright, so what we're saying here is we have the square root of 4, all of that to the 5th power, and then to simplify this, we just follow order of operations. So our first step in order of operations is parentheses, and inside of that parentheses, we have a square root of 4. So the square root of 4 is 2, and we raise that to the 5th power, and then 2 to the 5th power is 2 multiplied by itself 5 times, which is positive 32. And you should not need a calculator for any of these. Your instructions in the homework and the textbook are actually to evaluate without a calculator. So if you don't know something, you're going to have to use trial and error to find what the nth root of that number is. Okay, so let's look at example 7. Now this one looks a little bit different because we have a negative exponent here, but that's okay. That's why we have been writing them all out first. So let's look at 9